7 electrons in its outer shell. So it's going to want to get that 1 from sodium to be more stable. So when they bond together, it kind of looks like sodium is giving an electron to its chloride. But it's not like they don't disperse, they're still 1, even though sodium gives that electron to chloride. So, and then if you notice at the bottom in those shapes, you see that the Na has a plus. That's to show that it is a cation, meaning that it gave up an electron. And you can see that Cl is negative, and that means that it is an anion because it gained that 1 electron from sodium. So our types of chemical bonds are going to be, the next one is going to be a covalent bond. So this results from the sharing of electrons between 2 atoms. So instead of one giving up another one, the 2 share them. So this bond can be either polar or nonpolar. So in a nonpolar bonding, a covalent bond in which the bonding electrons are shared equally by the bonding atoms, resulting in a balanced distribution of charge. So let's say if you have like a Hershey's candy bar, you know they come in those squares, so you can break it apart and share it. So a nonpolar covalent bond would be like splitting it in half and sharing with a friend or someone else. So the polar covalent bond is the atoms have an unequal share of attraction, resulting in an unbalanced distribution of charge. So say if you had to share with your little sibling, I'm pretty sure you wouldn't want to give them half, so you would give them a smaller piece and you would have the bigger piece. So that is the share of an electron. So there's going to be a charge because one is pulling on has a greater pull on the electron than the other one does. Even though they're sharing, one's going to have a greater pull. So the difference in electronegativity, so you guys remember this? We talked about this on Monday, I believe. If you were here yesterday in class, we did a lab on this. So what is the most electronegative element on the periodic table? You guys remember? No. Does anybody on Zoom remember what the most electronegative atom on the periodic table is? If you don't want to say it out loud, you can send it in the chat also. But if anybody, I don't know.
Fluorine?
Yes, good job. Whoever said fluorine. I don't know who said it, but oh, Dave. Yes, good job, Dave. So your most electronegative atom on the periodic table, remember, is our fluorine. So it's going to increase as it goes across that periodic table. So if you look at this chart, I also don't copy this down. I have it's on that worksheet that I gave you guys in class. And if you're on Zoom, I put something on Canvas. It's called a bonding cheat sheet. It has this on there for you already if you didn't want to copy it down. And it also has some other stuff on that cheat sheet for you. So, so the difference in that electronegativity is what is going to change these bonds. So I'm going to go to the next slide. So here you are. So you already know previously that electronegativity does what when you go left to right? If this is your most electronegative, your fluorine, when you go across, it's going to what? Increase. There you go. So it increases as we go across the periodic table. So if you look at all these numbers, it increases going up and to the left, so you can see these values. So you could use this chart, say if you had, like if we did our sodium and our chlorine, we can see that that is greater than, what that number is, it's greater than 1.7, that distance. So that's how we know that would be an ionic bond. So I'm going to go to the next slide, and I'm going to give you guys a couple seconds to use that trend. You guys want to write this down, I'll go back to the electronegativity slide for you. But this is, I want you guys to take a second and do this really quick. And I'll go back. I'll write it down. So, what type of bond would occur between NaCl? You guys shut up, we just read that. What kind of bond would that be? Anybody on Zoom? You can just shout it out, you guys in class too. So use that electronegativity. You could use that that electronegativity chart I have to look for you guys. So this is the one we just talked about. It's an ionic bond. It's between a metal and a non-metal. And you can use this chart also that I just said, that if you do 3 minus 0.9, it's greater than 1.7, so that's going to be an ionic bond. What type of bond would it be between carbon and carbon? So it's between two non-metals, so what do you already know that it's a what? So we know that an ionic was between a metal and a non-metal. So if a non-metal and a non-metal, then what kind of bond would it be? So if a non-metal plus a non-metal creates a covalent bond. If you go back and look at the distance, so you have carbon and carbon, so it's going to give you 0, and it's going to be a non-polar covalent bond because 0.3 or less. You look at your carbon and your oxygen, it's going to be another covalent bond between a metal and between two non-metals. Go back and you subtract 3.5 minus your 2.5. And because it's between 0.3 and 1.7, we can say that it is a polar covalent bond. So ionic bonding makes ionic compounds. A compound composed of positive and negative ions that are combined so that the numbers of positive and negative charges are equal. Most are going to be crystalline solids. Examples of those is going to be your NaCl, which is table salt, MgBr2, and Na2O. A formula unit is the simplest collections of atoms from which an ionic compound formula can be established. So your formula unit is NaCl and your MgCl2. That's how you write a compound. For the MgCl2, it's a ratio. So with every 1 magnesium atom, you'll have 2 chloride atoms. We'll explain into later as to why that is the way it is. So your electron configuration changes. I kind of went over this on Monday too when we reviewed to show you guys what happens when they go from ions. When ions are formed, so they go from what they normally are to ion state. So electrons are transferred from the highest energy level of one atom to the highest energy of a second atom, creating noble gas configurations in all atoms involved. Normally electrons move from a metal to a non-metal, resulting in a net charge of 0. So remember, your noble gases are in that last group on the periodic table. So if we started with sodium, we would end with 2s2 and a 2p6, and that is the same electron configuration as neon. And then you look at your chloride, so you go from 3s2, 3p5 to a Cl negative, and that's going to change that configuration to 3s2, 3p6, which is the same as argon. So, characteristics of ionic